what I'm showing you first off is the object class, and what you understand is every class in Java extends the object class, and so and that means everything I'm showing you is inherited by every other class. And so in the object class, you have a clone method, an equals method, finalize, all these different methods. The ones I want you to focus on are the toString method and the equals method. And your job is to make your own new version of those. But you need to understand, any object you ever made, you could call it equals method. You could call it toString method because they're defined in the object class. All right. The thing is, the way it's originally defined isn't the way we generally want it to work. In other words, if you do an equals, ideally, it would compare, like if you had two separate objects with all the same data, it should return true. But that's not what it does. Okay. Imagine this: you have an object, okay, and it's a string object. Let's make it easy. You have a string object, and so you have a variable storing a reference to it. So string 1 equals that object, but string 2 also stores reference to the same object. That could happen. And in that case, then this equals method would return true. That's the only case it would return true. And if, on the other hand, you had two separate strings, both storing the exact same characters, same case, and so it should return true. This method, and so what you do is, like, let's say string 1 is the first string, the other variable string 2. If you do string 1 dot equals string 2, then this method would return false. Because think about it, what do those string variables store? The locations of those objects, right? The memory reference, and they're different objects. The variables store different things. And I'm saying that's what the equals method normally compares. And so we don't want that. So you should make it so when you compare your objects, if they have the same data, it returns true. So we override this original. And then there's the toString method, which we also override, because look at this. I'll show you right here. What it normally does is gives you the class name, then an @ symbol, and then a thing called a hash code, which I'm not going to explain, but we don't want that. What your toString method should show you is just the current values of all your variables. Okay? And so once again, keep that in mind. Like here, I'm going over the worksheet, and you can write this down. This is on the front, it was talking about the gas guzzler class. And so if you look at it, once again, we're putting in our own toString method, our own equals method, which is what you see here. If this was not here at all, then our class would have a toString method, and it would have an equals method, but it would be the original that I just described. So when you make your own class, which most every lab you do, you're going to make a class like this. And when I say class, I'm saying a class like this where you're going to instantiate it. So we're going to make gas guzzler objects. Then you should give it a properly defined or constructed toString method, an equals method. Now, I'll come back to this. Let's look at the gas guzzler class. First of all, if you look at this part here, it has 5 variables altogether. So there's 2 ints, 2 strings, but then up here, the styles variable is an array of strings. Now, that one's static, so that's a class variable, whereas the rest are your instance variables. So in other words, every time you make a new gas guzzler, it gets its own copy of the year, the name, the color, and the style. And so, in fact, if I go down back to the string method, look at this. What variables do you see there? The year, the color, the name, and the style. Because every gas guzzler object will have different data, or at least its own data. And so that's what you should see when you call the toString method, values of all the variables. Another way to put that is that the toString method should return the current state of the object, or a string that represents the current state of the object. And so when I say that, the current state of the object, all I mean is the values that each of the variables are storing at this moment in time. Now, frankly, in this example, which of these variables, once you create one of these gas guzzlers, which variable could change? I'm thinking only the color. I mean, once you make a car, you can't change the year that you made it. That's not going to change. You can't change the type of car. And if it's made a convertible, you probably won't convert it, change it into a hardtop, In theory, you could, but almost certainly not. So in reality, in this example, the only thing that's probably going to change is the color, ever. But in theory, they all could change them. And so that's what, like I said, the current values of all the variables is what the toString method should return. One more thing, look at this. All this toString method returns is the variables themselves, with spaces in between. In other words, what I'm saying is here that made sense. I mean, it reads well. This object is a 2016 red Mustang convertible. That sounds good. You know what it means. But in some cases, you'll want to add some labels in there. So you won't just have the variables. You'll have like the word's account number, and then the account number, and then the current balance, and then the number right after that. And so your string should show more than just the values. You should have labels too. But I'm saying it should always have all the variables. All right. So that's the string method. The equals method is harder. Before we get into this, let's get the right perspective here. Once again, we're talking about the gas guzzler class, and when all the code you see here defines a single gas guzzler object, right? In fact, before we get back to the equals method, let's talk about this class. How many constructors does it have? Just one, where it says gas guzzler. And normally would you say public first? It's not wrong to not say public, but normally we do that. Now I want to compare that to these methods. Like the get year method, the return type is int, right? The get color, the return type is string, and so forth. Is convertible, return type is Boolean. Our gas guzzler constructor has no return type. And that's how Java knows it's a constructor. It needs to be the same name as a class, and it has no return type. Not void, it's nothing. There's nothing there at all. Okay? Now, let me actually bring up the gas guzzler class. I'll read that? Yes. Now, I added some things to this, but everything's still there. There's the variables as I was describing. Here's the constructor. But I wanted to show you, so here's the gas guzzler class that defines that kind of object. Over here is a separate class with the main method where I created various gas guzzlers, and by calling the constructor that I just showed you. So, first of all, how many different objects, gas guzzler objects, did I create?
4.
3. There are 4 variables, yes. But how many times you see the constructor being called? Only 3. It says new gas guzzler here, here, and here. And once again, we're calling this constructor that we created right here. Now, look at this. These variables here, they're inside the parentheses, those are called the parameters of the constructor. And so it has 4 parameters: an int, a string, and then another int. And so when I called it, I had to give it an int, a string, another string, and then the int. Once again, corresponding to the year, the color, the name, and then the style. And let me go back to this. Once again, the styles array is defined for the whole class once. And then the style variable, every object has its own copy of that variable. That's going to be an int that really should be 0 or 1. 0 if it's a convertible, or 1 if it's hard dot. Okay? Now, so every time you call this gas guzzler, it's going to create these 4 variables, because understand, it's creating an object, it's constructing an object, right? And part of that process is to create these 4 variables, and then it also stores those values into it. Now, look at this. I want to show you kind of the path the data follows. So, like, let's just take the year, 1997. That value, first of all, gets stored into this parameter here, all right? And then that year there is also the same year here. The goal is to get it up here in the instance variable, because this is a variable that you can use all through your class, right? And so once again, right here, it just needs to store from the parameter into the year. And since they're identical names, you have to say this dot year to tell Java that you mean the parameter up here. And so that's what this does. It first of all creates an object and creates these variables as part of that process, but then it takes all the information that's passed into these parameters and copies it out of those parameters and into the instance variables. So now your object's been created, all the data's in there, and you can use all the methods you want because the data's in place where you want it. Okay? And once again, I called the constructor 3 times. I have 3 different objects, and each object has a copy of these variables. But this variable was only created once before I even started creating objects. And so it was created, and it was given this array at the beginning because it's a static variable or a class variable. Okay? All right. Questions so far? Now, then let's look at the methods. Now listen, we have 4 instance variables, right? 2 are ints, 2 are strings. Generally speaking, For every instance variable, you're going to create a setter variable and a getter variable method. A setter method that just takes a parameter and stores into that. And notice here, I took a little different approach. I made the parameter name different. Then it was easy, because then it just, when you look at this code, the only year it knows of inside here is the original defined up here. So I don't have to say this.year. I could say, if I could type, I could do that. But you don't have to here. All right? And so that's your options. If you make the parameters identical, then you have to set up like this. But if you make it a different variable name, well, then it's simpler, really. But now look at this. So these just set each variable. These just get each variable. And once again, the return type should match the variable. The year is an int, so it returns an int. The color name was string, so it returns a string. This is a little different. I didn't return the actual style, like the number, but the word from the array. That's why the return type is a string. Now, one more question. Okay, first of all, like I said, you should have one of these methods for every variable, for every instance variable. Then you could also make a setter method like this if you want to, that just resets all of them at once. You don't have to. But here's my question. If you did create a method like this that sets all the variables, I mean, look at it. The code in this is identical to the code in the constructor, right? So what's the difference? What's the difference between calling this constructor and calling this set method? So I'll come over here, and I could say, gas guzzler with those parameters. But what if I did set car with those parameters? Anyone want to explain the difference? Yeah, in every case, the array is created before anything happens. So understand that if it's a class variable or class method, all of that is created and made accessible before you start running any of your code. So before you even, instantiate any objects, you can access that array. I'll just explain. But for sure, they're both running that code, and they're both that same code. That's going to happen in both cases. But the constructor constructs an object, right? So before it runs that code, it has to create an object, and part of the process of creating an object is create those 4 instance variables. And so that's what that gas guzzler constructor does. It creates the object first, and then stores the values in those variables. And so that's what it runs that code. Whereas the set method, you can't even run that set method until you already have an object, right? And so you create the object, the variables already exist, and then let's say you've created it, you want to change what it stores. Well, then you call the set method, and it does the same code, but it's storing those values into variables that were already created. All the set car method does is those 4 lines of code. Whereas the constructor has to build the object first, and then run those lines of code. Okay? And so they look very similar, but they're very different. And so I want you to be clear about that. Now, listen, once again, we're talking about how you build a typical class. And so you give the variables, you make a constructor, give it setter methods and getter methods, but you also need to give it an equals method and a string method. And this is besides any just whatever methods that you want it to, do its normal function. The string method, like I said, it just shows the current state of the object. Just all the variables go there. And okay, let me go back to the worksheet. I have it colorized there. So I wanted to talk about the equals method. Like I said, what should happen is if you're comparing this gas guzzler to another one, and if they're the same in every respect, then and only then it should return true. So the heart of this is right here, where it says return year equals other.year, name equals other.name, and so forth. That's all the equals should really do is compare all the contents. Okay. Now you have to get the details right, and the equals method is kind of tricky. Because first of all, you have to remember, we're trying to override the original found in the object class. And so you have to put the word object there as a parameter. You don't have a choice, all right? The variable, I used O here. You don't have to use O. That's optional. But you have to put object there. Now the return type's Boolean. That should be obvious, because it's a yes/no question. Is this one equal to the other one or not? So you got to remember that, though, that the return type's Boolean. Now, like I said, the idea is we're comparing the year of this object to the year of the other object, and then the name of this one to the name of the other one, and so forth. So the catch is, what kind of object has a year, a name, a color, and a style? Well, a gas guzzler object. My point is, we have to put the word object here as a parameter type, but it should be another gas guzzler. But listen, if you make your variable type object, it could store a reference to anything. It could be a string, it could be an array, it could be an array list, it could be a gas guzzler, it could be a catch, it could be whatever kind of class you've ever heard of or want to make or whatever. Okay, it could be anything. And so what I'm saying is, before you run into the code you want to run, you need to ensure that it really is a gas guzzler. And so that's what this first line does. It says, O.instance of gas guzzler returns true only if O refers to a gas guzzler. And if it's not, well, then they're not equal, obviously, so you return false. And by putting that there, you ensure that everything after it will be safe to run. Because if it's not a gas guzzler, you won't be running this code. Hold on one second. Now listen, I want to talk about the second line here. Once again, we always do it this way. Because we have to make this a type object, when in reality it should be a gas guzzler, we make a new variable that's of gas guzzler type, and we store it into that other variable. And look at this. What is O storing? A reference to our object. What is other storing? Well, the same thing. The difference is, what if you try to use O, the compiler doesn't know it's a gas guzzler. And if you use other, it does, because we said it is. And so I want you to understand this typecast that's here, it's not converting anything. People think that's what it's doing. It's not converting the object into a gas guzzler. It is a gas guzzler. You're telling the compiler that you know it will be a gas guzzler. And so you can do this then. You can store out, you can copy out of O and into other, and it works. It makes it compile. Okay? One more thing we need to talk about. You notice in the actual code down here, sometimes it says equals, like the equals operator, and sometimes it says equals method. And you can't do one or the other all the time. You have to choose. Look, if you look back at your variables, 2 of them were ints, and 2 of them were strings, right? The ints, we call those primitives because those variables store the actual numbers, right? And so if it's, let's say the year is 1997. If you were actually looking at the computer, find where it's storing the year, it's storing the number 1997 right there. It's in binary, but it is actually the number 1997. Whereas if the string name, or let's say the color is red, if you go look in memory where the color variables, set aside, there's memory set aside for the color variable, you will not see the characters red. Even it's not there, because once again, we're talking about strings. Strings are objects. When I say object, it's not just the characters, it's all the methods and all that. So it's this big object. And what is the variable actually storing? The memory reference, or memory location of the object, right? And so you shouldn't use the equals operator on objects. So look at this. Let's talk about this. The equal sign compares the contents of the variables, which is appropriate with the year. Because this year, if the year is 1997, then this variable stores 1997, and another year is also 1997, and that's how you compare them, okay? You try that with strings. If you did name equals other name, then it's going to compare the contents of variables, which is the memory reference. And when would it return true? Only if they're actually referring to the same object. You don't want that. So I'm saying, do not use an equal sign with a name, okay? You can. It'll compile. It just won't behave the way you want. You should use an equals operator. Equals method if you're comparing objects. All right, let me go back to this. What if I came back here and I try to do year dot equals other dot year? What would happen? It won't even compile, yeah. Because what is year storing? Just the number 1997, right? It's a primitive. We call them primitives because they're just numbers. They're just values. There is no object. If there is no object, there are no methods. You can't do the equals method or string. There is no method at all. Okay? And so I'm saying, if it's a primitive, you have no choice. You can only do equals. Because there are no methods. If it's an object, You shouldn't use equals equals. You should use equals method. Okay? But you can use equals equals. It just won't do what you want. And by there's an exception to all this that I'll deal with when we get to it. But this always works. Okay? And so, all right. Hold on. I'm going to save this. Turn